The manufacture of an axle stub for commercial vehicles begins with the setting of a header. Then the axle stub is drop forged using a counterblow hammer. After clipping, the tubular stepped inner contour of the workpiece is formed on a hydraulic press by means of hot extrusion. The tip of the punch glows red during the process. Hot sizing follows. These axle stubs are manufactured with a combination of drop forging and hot extrusion. The correct mass distribution during the manufacture of a front axle beam is achieved through reducer rolling. The workpiece with a mass of more than 100 kilograms is fed by a manipulator through the roller set in several passes. Then it's transferred to a hydraulic preforming press. The workpiece is bent and the final shape of the axle beam is already visible. The preformed part is put into a forging die by a manipulator. And is finish forged in a counterblow hammer, the die halves of which move towards each other. An additional manipulator extracts the workpiece from the die and puts it into a trimming tool to clip away the flash. Finally, the front axle beam for a commercial vehicle is sized, removed from the tool, and placed on a floor conveyor by a robot for transport. The annual production of the German forging industry amounts to around 2 million tons of forged parts, approximately 2/3 of which are drop forgings. The production of 7 common forged parts has been shown so far. Additional massive forming processes will now be explained. By cold extrusion, symmetrical, solid and hollow parts can be manufactured with increased precision on either manually operated machines or fully automated machines when higher volumes are required. Forging on horizontal upsetting machines is a forming process utilizing 3-piece tooling. The workpiece is fixed between 2 clamps and formed with the punch. Afterwards, it's clipped lengthwise and widthwise. This is the only forming process which is capable of manufacturing the undercut form of an excavator tooth. Ring rolling uses a pre-forged and punched disc to form a seamless ring on a ring rolling machine using partial forming in a roll gap. Open die forging is a forming process with free-form tools. Hammers and presses are utilized to partially form the workpiece in multiple strokes. For example, auxiliary dies allow for the formation of a shaft with 2 stems. Manually operated or automated rail or free-moving manipulators can move open die forgings safely and easily, even with a weight of over 100 tons. Forged parts come in a tremendous variety of shapes and sizes. The wide range of forgeable alloys and various heat treatment procedures enable an optimal adaptation of forging characteristics to the various applications. The processes of manufacturing forged parts guarantee consistent process control. The outstanding mechanical properties of forgeable alloys and the resulting high loading capacity support the trend towards lightweight construction, which is increasingly important. Forged parts are free of surface and internal defects, demonstrate reliable material characteristics, and can be manufactured to extremely accurate dimensions. Forged parts show high levels of machinability, Often they're sold as ready-to-fit components or as parts of systems. When subjected to high loads, wear-resistant components are required, for example for vehicles. Only forged parts allow this. This film has provided just a brief overview of the manufacturing methods and the wide range of applications for forged parts. The German forging industry utilizes all kinds of manufacturing processes and is capable of supplying economical products of all descriptions as a result of its developmental capacity. Further information is available from these sources.